So we're going to continue in section 4.1 talking about inverse functions. And in the last video we talked about one-to-one functions and showing that a function is one-to-one if it does not have a y value that repeats. Okay, we already know that it can't have an x value that repeats, but if it has a y value that repeats, then it's not one-to-one. And so we're looking for these functions, just to kind of give you an idea, that are lines or kind of this shape, kind of that S shape. Parabolas are not one-to-one because they do not pass the horizontal line test, and so that's not one-to-one. And so we're looking for these shapes where there's not going to be any minimum or maximum. It's going to be continuous left to right or right to left. Okay, and so if we know the graph, some of these we're going to know the kind of an idea about what the graph looks like, and so that can be helpful. And so as we talk about these one-to-one functions, an inverse function is a function that is, or inverse functions are functions that are one-to-one and they undo each other. Now when we say undo each other, what we mean is that if we were to put in, if we were to solve for x in one of those functions, then we could turn around and put that into the other function and also solve for x. So they're going to, where one multiplies, the other one's going to divide, or where one adds, the other one's going to subtract, and that kind of stuff. And so we're going to talk about how to know if equations or functions are inverses of each other, and then how to find the inverse pretty easily. And so notice here in the middle of the screen it says let f be a one-to-one function and g be the inverse of function f if f of g of x, okay, this notation, this is a composition, if f of g of x is equal to x for every x in the domain and g of f of x is equal to x, so for every x in the domain of f, then the functions are one-to-one. Okay, so what we want to do is we want to be able to show that when we do the compositions, we put one function into the other, it's going to give us x. And then when we do that from function f going into function g, and then function g going into function f, they both should give us that x. So let's try this and see how it works. So again, we have f of x, which is x cubed minus 1. We have g of x, which is the cube root of x plus 1. And we want to know, are they inverses? So what we're going to do is we're going to find f of g of x. And so that means we're going to take f of g of x, remember that alternate notation, meaning we're going to take function g and put it into function f. So that means we're going to find f of the cube root of x plus 1. And so when we put the cube root of x plus 1 in here for x, we're going to have the cube root of x plus 1 cubed minus 1. Now, notice this is still x cubed minus 1, but in place of x, we've put this x cubed, or the cube root of x plus 1. Well, now when you simplify that, the cube root and cubing that term cancel each other out, leaves us with x plus 1 minus 1. And 1 minus 1 we know is 0, and so it leaves us with just x. So this composition, f of g of x, is equal to x. That's what we wanted to happen. Now, it's not enough to just show that composition. We got to go show the other one too, where we take f and put it in function g. And more than likely, it's going to work out too, but we need to make sure that we do both of these. And so we're going to find g of f of x. And so that's g of f of x And then f of x is x cubed minus 1. And so in place of x in function g, we're going to put x cubed minus 1. So in this case, we've got the cube root of x cubed minus 1 plus 1. And so we want to simplify that. So that parentheses is not necessary. I've put it there so you see that's in place of x. And so the negative 1 plus 1 is going to be 0. It's going to cancel out. So it's going to leave us with the cube root of x cubed. And again, that radical and that power cancel each other, and you get just x. So g of f of x is also equal to x. And so because both of these functions, when we do their compositions, they both give us x, that means this must be a one-to-one, and these two functions must be inverses. And so the question is g the inverse of function f? And we're going to say yes. G is the inverse. And there's our answer. Now, you may have questions about that. Again, it goes back to that definition on the previous slide that just said that if you can do their compositions and you get x for both, then they are functions. They are inverses of each other, okay? And so that's what we're showing. We're going to do their compositions. We're going to show that if they both equal x, then we're good. So let's try this one. In fact, what I'd like you to do is pause the video, try this one on your own. Again, you're going to do the compositions to see if they both give you x. If they do, then they're inverses. If they don't, then they're not. So take just a second, pause the video, and then I'll come back and work it for you. Okay, so hopefully you did pause the video and you've worked this one. And so again, we want to show that f of g of x is going to be equal to x, hopefully. And then we also want to find g of f of x. And hopefully we're going to find out that it is also equal to x. And if that happens, then they are inverses. So f of g of x. Again, that alternate notation says we're going to find f of g of x. Well, we know g of x, right? We know that's this function 1/2 x minus 5. We're going to substitute that in to function f. And so we have 2 times 1/2 x minus 5 plus 5. Well, as we simplify that, we're going to distribute the 2. Well, 2 times 1/2 is 1x. 2 times negative 5 is negative 10, and then plus 5. But negative 10 plus 5 is negative 5, and so it's x minus 5, and that's all you can do with it. And so it doesn't give us x. And so these two functions, we know without ever doing the g of f of x, we know these two are not inverses because their compositions didn't both give us x. And so the question is g the inverse of f? We're going to say no, g is not the inverse. Again, we didn't even have to show what g of f of x was because f of g of x didn't give us the x. Again, if you have any questions about that, shoot me an email, let me know. I'll try to get back to you as quickly as possible. All right, so as we continue to talk about inverses, by definition, the inverse function, if functions are inverses, let me start there. The domain of function f is the range of f inverse. So we call this notation f inverse. Okay, that is not f to the negative first power. That's not what this says. Okay, we say that as f inverse, or the inverse of f. And so, if we have these two functions, f and f inverse, the domain of f is the range of f inverse, and the range of f is the domain of f inverse. Essentially, the x and y switch places in the two functions if they're inverses. Okay, they just switch places, x and y. And so what we're going to do here with these two sets of ordered pairs is we're going to find their inverses. Okay, so we have function f. F inverse is going to be found by simply flipping x and y in every ordered pair. And because, again, the domain of x, the domain of f is the range of f inverse, and the range of f is the domain of f inverse. And so we're just flipping the x and y's. And so our order pairs then would be 1, negative 2, 0, negative 1, 1, 0, 2, 1, and 2, 2. Now, here's the issue with this problem, and this problem comes from the book, and I'm not crazy about this problem because you'll notice that the original function wasn't 1-to-1 because you have a y value that got repeated. And so when you do the inverse now, you have a relation that's not a function. Okay, so that's my only issue with this problem. The way it's laid out is this last point, it's got a y value being repeated, and so the inverse would also not be a function. Now, for the sake of this problem and explaining how to find the inverse, it's not a huge deal. Okay, but I do want to point out that that is an issue with this particular problem. And so as we're looking at each of these and finding their inverses, it is just that, flipping x's and y's. So look at function g. If we're going to find g inverse, again, we're just going to flip x and y. So first order pair would be 5, negative 2. The next order pair would be 2, negative 1. The next order pair is 1, 0. The next one is 2, 1. And the last one is 5, 2. Now, again, very similarly, you got an issue here because the original function wasn't 1-to-1 because you had a 5 that got repeated in the y value. You also had a 2 get repeated. So when we found the inverse, well, now all of a sudden we don't have a function, right? So again, this is a problem out of the book. I'm not crazy about it, but I hope it still illustrates the point that when we are trying to find the inverse, you just flip x and y. Okay, that's all you're doing in this one. We're about to get into some other problems with finding the inverses, and it's that same idea of flipping x and y. So I'm going to stop this video. I'm going to pick up with another video next that will finish up this first section.